Hi, my name is Gautami, studying second MCA in JNTU College, Anandapur. Today I will discuss about one topic in Linux programming. Topic name is comparison of IPC mechanisms, in which first of all we will discuss about what is IPC. Next we will discuss about various comparison mechanisms in Linux. These various comparison mechanisms are pipes, FIFOs, message queues, shared memory, and process semaphores. Next, we'll discuss about what is IPC. IPC means inter-process communication, in which inter-process communication mechanism where one process is communicates with another process. This is a IPC mechanism in which communication means exchange of data. Exchange of data means communication. In IPC have some directions. There are three directions in IPC. These three are unidirectional. This means only one direction. Bidirection, in which only have two directions. Multi-direction are more than two. These are directions in IPC. Next example of IPC. In which example we print file names in a directory. In this we have used ls command is used to outputs of the file names. LPR commands is used to input, in which these ls and lp are two separate processes. So we can use pipe symbol. These two are combined. This is an example for IPC. Next we will discuss about types of IPC mechanisms. These are pipe, named pipe, message queues, shared memory, and semaphore. First, pipe. Pipe means allows the flow of data in one direction only, in which flow of data have only one direction. Next, named pipe. Named pipe means pipe with a specific name. It is called a named pipe. Next, message queues. Message queues means message passing using a queue. It is a message queues. Next, shared memory. Shared memory allows only interchange of data through a defined area of memory, in which we can use some area of memory. Next, semaphore. Semaphore is used to solving problems associated with synchronization and avoiding race conditions during sharing. These five are types of mechanisms. Next, we will discuss all in detail. First of all, pipe. Pipe have two directions, two ends. Pipe connects two ends to allow transfer. It is a one-way serial communication channel. That means only data can flow only one direction. Next, pipe have two ends. One end have output. This is also called write end. Another end is also called input, also called read end. Pipe have only limited capacity. Pipe provides automatic synchronization, in which pipe read blocks are no data. There is no data in read block, full of data in write block. This is a pipe. Next we will discuss about pipe usage. In pipe usage, by using by using pipe symbol we can use. Next, in programming or C, we can use P open, P close. Using system call, using pipe. Communication as with another FT using system calls read or write. Anyone you can use. Next we will discuss about FIFOs. FIFO means first in first out. It is also called as named pipe. FIFO means a pipe with a name in the file system. FIFO is also called as named pipe. In these, properties are identical to those of a pipe. Properties are including a serial communication. That means pipe also have serial communication, which is now termed as so we can term it as first in first out. Except that now processors can be unrelated, achieved it being a device specified special file. FIFOs persist irrespective of process existence, and any process can operate on it. These all are about FIFOs. Next, FIFO usage. On cell, we can use FIFO by using creation, using mknod or mkfifo. By using communication using cell, commands are scat or echo. and so on. In programming ASCII, by using creation system call, use mknod, open, close. By using library function, use mk before f open, f close. But communication, use system calls are read or write. Library functions are fread, fwrite, fputs. This is a before uses. Next, these these before uses on cell. By using cell, it is a example of a cell. Experiment on cell. These commands are used by on cell. This is a before. Next we will discuss about shared memory. Shared memory is the simplest and also fastest form of inter-process communication, in which shared memory, all process shares same piece of memory. This memory is shared between some different processes, so synchronization is needed. This is a shared memory. Shared memory synchronization means only one process should be allowed to read or write at a time. Only at a time we can use any one process. We can do this using a semaphore. First, in the shared memory, first create shared memory with a specific key using a SHMGET, in which compulsory we can use specific key. Next, attach the memory to process address space to make it available for that process using SHMAT. By using SHMGET is used to create shared memory. Next, this memory address process address space to make the available in the process using a SHMAT. This is a shared memory. IPCS space -m. This command is used to see the list of shared memory in our PC. This is a shared memory. Next, we will discuss about SHMGET and SHMAT by on cell using SHM_ID equals to SHMGET key bytes flag, in which key means unrelated process can access same shared segment by specifying same key. It is a key. Next, bytes. Byte, number of bytes in a segment. Flag is used to IPC_create by using pipe symbol, IPC_excel, in which all you can use pipe symbol. Next, char space asterisk symbol SHM. SHMAT, SHMAT, parenthesis, SHMID PTR flag, in which SHM_ID is used to shared segment identifier returned by SHMGET. PTR. PTR means pointer. Pointer that specifies where your process is address space you want to map shared memory. Flag. SHM_RND, SHM_RDONLY, in which we can use SHMDT. It is used to detach the shared memory from our process address space. SHMCTL command, SHMID flag null. These all are about SHMGET or SHMAT. Next we will discuss about message queues. Message queue means process communication by means of IPC messages. Message sent goes and stays on IPC message queue. Means message only can pass by using a queue, in which there are two processes until another process reads it, like FIFOs, unlike FIFOs. By using FIFOs, typically flows FIFOs. Unlike FIFOs, we say full certain urgent messages before they reach the front. In the FIFOs, exist independently on both sending and receiving messages. But FIFOs always ready, no need to open or close. Like FIFOs, data transfer between unrelated process, but unlike FIFOs, no synchronization is used between open or close. This is a message queue. Message queue uses. In shell, we can use some commands. By using creation, we can use IPCMK space -q. in the bracket minus p mode. Get information, in which a message can be getted by using the IPCS minus q minus IID. This is a command is used to get the information on cell. Next, using remove command, by using remove the data from the cell, we can use IPCRM minus q message key pipe symbol minus q message ID. This is a message queue usage in cell. Next, you can use programming in cell using system calls. Create or access message queue using message msgget message get command. Next, send the message by using the msgsnd. This command is used to send the messages in programming way in C and C. Receive messages. Message RCV. This command is used to receive the message in C. Other message queue operations. Some operations, message CTL, helper function, in which you can use helper functions. This is a FTOK after we use parentheses. These all are about message queues uses. Next, message queue operations are creating or connecting a message queue by using a key int message get key underscore tk int message flag. It returns message QID on success. -1 is an error. This is a message queue operations, in which key means system-wide unique QID for a message queue. Process connect to a particular message queue using a creation key. Message underscore flag. Operations pipe symbol for permissions. IPC create IPC Excel. This is a message queue operations. Next we will discuss about mapped memory. Mapped memory means permit different process to communicate via a shared file. This is a mapped memory. Mapped memory forms an association between a file and process memory. Mapped memory forms association between the file and also process memory. This is a mapped memory. Linux splits the file into paged size strings and then copies them into the virtual pages so that they can be made available in a process address space. This is a mapped memory. MMAP call is used, in which we can use MMAP call. Next, MMAP call. It is used MMAP after we use address length, PROT, flag, FD, offset, in which address means address at which you would like your Linux to map the file into process address space. This means null. This is a address. LEN, length of the file in bytes. PROT, this is some commands. PROT read, pipe symbol, PROT write, or PROT Excel. These are the commands. Flag is used. Some commands, map underscore fixed, map private. These are used to store write to new file. Map shared, store the write immediately to your file, to not buffer it. FT means file descriptor. File descriptor opened to a file to be mapped. Offset from beginning of your file from which to start the map. This is a MMAP. These all are about comparison of IPC mechanisms. Thank you.